Hey there, welcome back. We're going to talk about some special functions today. This section, we're actually going to split it up into like 3 different videos. The first thing we're going to talk about is absolute value functions. So I want to know, how can I graph, what's the easiest way for me to graph an absolute value equation? And then I want to be able to look at a graph of an absolute value equation and go backwards and write an equation. So how do I do that? And then just in general, to help deepen our understanding, can we create a list of characteristics of a absolute value graph? Like in general, what should they look like? So let's go through there. Okay, so we're going to start with the most basic absolute value graph. F of x is equal to the absolute value of x. When you're graphing, every first step should be to find the vertex. The vertex is what I call x sub v, y sub v. It's just a way to name the point, like we have x1, y1, and x2, y2, so that we're naming points to calculate slope or use the point slope formula. Same difference, we're just calling it the x-coordinate of the vertex, x sub v, and the y-coordinate of the vertex, y sub v. The argument is the piece right between the bars. It could be as simple as x, it could be 3x plus 10, it could be x minus 2, but whatever that argument is, you want to pull it out of those bars and you want to solve for the variable. In this case, x. This one is super simple because all I have is x, so I set it equal to 0. Okay? Then to find the y-coordinate, I plug that x-coordinate back in. So f of 0 is equal to the absolute value of 0. So my vertex is going to be 0, 0. That's a super important point to find with absolute value. It's probably the most important point to find. Then what we're going to do is we're going to make a table of values, and we're going to put our vertex in the center, and then we're going to find a couple points to the left and a couple points to the right, okay? And we're going to graph those. So if I plug in a -2, I'm going to get out a +2. And if I plug in a -1, I'm going to get out a +1, 1, 1, and 2, 2. Just like that. I'm just plugging it into the equation and calculating. Now I'm going to put them on a graph. And notice the shape that I get. An absolute value, think of the word V for value, is going to always give you the shape of a V. Always. Always going to give you the shape of a V. Another always is the domain, is always negative infinity to positive infinity. The range is going to be the smallest y value. Here our smallest y value is 0. And our largest y value is going to be positive infinity. All right? So let's do some that are a little bit more complicated. We'll just gradually get a little bit more complex. Always start by finding the vertex. I set my argument, the red, what I have in red here, the part between the bars, I'm going to set it equal to 0. This one is self-solving. I mean, there's nothing for me to do. X equals 0 when I set it equal to 0. Then I plug it back in, and then I calculate. And so my y-coordinate is 1. So my vertex is the point 0, 1. And I'm going to put that in the center of my table of values. I'm going to pick points to the left, and I'm going to pick points to the right. And I'm going to calculate it. So I'm going to plug in -2. If I take the absolute value of -2, I get +2, and I add 1, I get 3. If I plug in a -1, the absolute value of -1 is 1. 1 plus 1 is 2. If I plug in a +1, the absolute value of 1 is 1. 1 plus 1 is 1. And if I put in a positive 2, the absolute value of 2 is 2, and 2 plus 1 is 3. Notice the symmetry. So I'm at 0, 1. Oops, that should be a 2. My bad. And then I'm at 1, 2, and 2, 3, and notice that I have symmetrical points, okay? So this should remind you a little bit of that even function. Absolute values behave like even functions. So if you were to ask to classify it, it would be neither. My range is restricted, and I have repeating y values. So let's specify the domain. This is always. I don't ever have to think, what is this? I know that it's negative infinity to positive infinity, just like my other continuous functions. My range, however, behaves like an even degree function. What is my smallest y value? Well, this is the point 0, 1. And everything is bigger than 1. So I'm going to go 1. And then this just keeps going up and up in the positive direction. Okay? Now another thing they might ask you to find are the x-intercepts and the y-intercepts. Here we have no x-intercepts. The x-intercepts do not exist, and the y-intercept is equal to 0, 1. Won't always be the vertex, but it could be. Let's try another one. Again, what's the place you have to start? You have to find that vertex. That's the most important point on an absolute value function. So I'm going to set my argument equal to 0. So x minus 2 equals 0. That means when I solve for it, x is equal to 2. Now I take 2 and I plug it into my function, and I get the absolute value of 2 minus 2. And what do I get? The absolute value of 0, which is equal to 0. So I get the point 2, 0. Okay? I'm going to put that point in the center, and then I'm going to find some convenient points to the left and then to the right. So I'm going to go 1 and 0 and 1 to the left, 3 and 4 to the right, and then I plug in. So I'm going to plug in a 0. 0 minus 2, that's negative 2. Absolute value, well, that is positive 2. 1 minus 2, that's negative 1. Absolute value, that's positive 1. 3 minus 2, that's 1. Absolute value is 1. 4 minus 2, that's 2. Absolute value is 2. And now I'm going to plot these points. So here's my vertex. This is the point 2, 0. And I'm going to have 1, 1. And I'm going to have 0, 2. And then 3, 1. Sorry, it doesn't like for me to make circles. And 4, 2. And then I'm going to sketch my graph. It's always a V. I'm going to specify my domain, which is just, I don't even have to think, always positive infinity to negative infinity. My range is going to go from my smallest y value. In this case, my smallest y value is 0. And then it continues on to positive infinity. My x-intercept, that's the point where it crosses the x-axis. That's 2, 0. And my y-intercept is going to be 0, 2. All right? So far, so good. Well, let's keep going. 2x plus 4 plus 3. So 2x plus 4 is my argument. This is my argument. All right? So I have to set that equal to 0 to find the x-coordinate of my vertex. So that means I get 2x is equal to negative 4, and x is equal to negative 2. And so then I'm going to plug that negative 2 in and calculate. So I get negative 4 plus 4, that's an absolute value, and then plus 3. So these go out, and it becomes 3. So my vertex is negative 2, positive 3. That point I'm going to put in the middle of my graph. Then I'm going to pick points to the left, and I'm going to pick points to the right. And then I'm going to plug in to my original equation all the way up here. Plug in up here, okay? So negative 4, 2 times negative 4 is negative 8, plus 4 is negative 4. Absolute value is 4. 4 plus 3 is 7. 2 times negative 3 is negative 6. Negative 6 plus 4 is negative 2. Absolute value is 2. 2 plus 3 is 5. Negative 1 times 2 is negative 2. Negative 2 plus 4 is positive 2. Absolute value is 2. 2 plus 3 is 5. 2 times 0 is 0. 0 plus 4 is 4. 4 plus 3 is 7. And I'm going to plot those points. My vertex is the point negative 2, positive 3. I'm going to make X's. I feel like that's going to be easier for me. And then negative 3, we are at 5. And at negative 4, we're at 7. And then at negative 1, we're at 5. And 0, we're at 7. And again, I'm going to make a V. Absolute values always make a V, and the domain is always, and every creature said, negative infinity to positive infinity. The range is going to go from my lowest y value, which is 3, and it's going to go on up to positive infinity. Notice that I don't have an x-intercept at all. X-intercept does not exist, but my y-intercept is, whoops, my y-intercept is 0, 7. That's my y-intercept. Okay, so far so good. All right, let's try this one. Notice that I have a negative out in front. That's going to turn everything upside down. Okay, that's going to turn everything upside down. I still have to find my vertex. I still have to set my argument equal to 0. So 2x is equal to 0. X has to equal 0. And then I plug that in. All right, so I plug in 0. So 2 times 0 is 0. The absolute value of 0 is 0. Take the negative of it, doesn't affect it, and I end up with 0 plus 2, which is 2. So my vertex is 0, 2. All right, I'm going to put that in the center, plug in a 0, get out a 2. Then I'm going to put points to the left and points to the right. And I make it easy on myself. So here's what I do. I plug in a negative 2. 2 times negative 2 is negative 4. Absolute value is positive 4, but I have a negative in front. So it becomes negative 4 plus 2. That's negative 2. I'm going to plug in a negative 1. 2 times negative 1 is negative 2. Absolute value becomes positive 2, but I'm going to take the negative of that, so that becomes negative 2 plus 2 is 0. So now I'm going to plug in a positive 1. 2 times 1 is 2. Absolute value is 2. Negative in front makes it negative 2. Negative 2 plus 2 is 0. And I'm going to plug in a 2. 2 times 2 is 4. Negative becomes negative 4. Negative 4 plus 2 is -2. So watch what happens here. I have the point 0, 2. That's my vertex. Then I have 1, 0. And I have 2, -2. And I have -1, 0. And then I have -2, -2. And I get an upside down V. That's caused by the negative sign in front. My domain doesn't change at all. -infinity to +infinity. Isn't that nice? My range is a little bit different. What are my smallest, see, my smallest y values? See how they keep going straight down to -infinity? So my smallest is -infinity. And what's my largest y value? Well, it's that 2. And now my x-intercepts, I now have 2 of them. X-intercepts are going to be -1, 0 and 1, 0. And my y-intercept is 0, 2. Sorry, I can't fit that in any nicer. This is a 0, and that's a 0. Okay. Now we're going to take a graph and work backwards into an equation. So here's the thing. Remember, the vertex is the most important point. So what is the coordinates of this vertex right here? It is -2, -2. We're going to plug this point into this equation for xv and yv. So I have f of x is equal to the absolute value of x minus a -2, and then it's going to be -2. So I get f of x is equal to the absolute value of x plus 2, and then -2. And it's that simple. On this one, my vertex is the point 2, 1. And I'm going to plug 2, 1 in for xv and yv. So I get f of x is equal to x minus 2 and then plus 1. And that's all you have to do. You just wrote the equation for an absolute value function. This will be our daily assignment. It's going to be a piece of cake. Well, I can answer any questions tomorrow. Thank you so much for listening, and I will see you tomorrow.